So now we have something a little bit different than the contributed papers. So this is an invited lecture, actually a keynote. So a keynote will give us some insight into, as I learned from Jaro, I wanted to mention something from the abstract, but he said it really doesn't make sense because it might be something different. So various important things that he finds. He's a very experienced researcher from the Technical University of Košice, the second largest city on the opposite side of Slovakia. So it makes difficult for us to collaborate, but we are really very close regarding the topics that we are interested in. So I'm very glad that Jaro accepted this invitation, and I won't take any more time with this. So there's a short bio, so I won't repeat these things, but I will give floor to Jaro. So please go ahead.
Okay, thank you very much. So thank you very much for inviting me. Yeah, the abstract was too general because I've started making my presentation only yesterday. So that's why it was too general. Fortunately, I opened the wiki to find something interesting about the software quality, but it was too long. So later on, I asked ChatGPT to prepare the presentation for me, but unfortunately, I also do not understand that. So therefore, I decided to speak about my personal experience. I realized that I work in the field of software engineering for more than 20 years. So that's really great because I can now speak not about what I will do, but I can speak about what I have done. So this presentation is about my probably past work in the field of software engineering in general. And you will see that I will mention few maybe research outcomes as well as lesson learned from the practice. So who I am, I work as a full professor at the Technical University of Košice at the Department of Computers and Informatics. At the same time, I'm the head of this department. It's the largest IT department in Slovakia with more than 1,000 students studying toward bachelor, master, and PhD degree. And it's an honor for me that I can say that software engineering is not just my research topic, it's my hobby and the passion. And as a proof that I'm working in such a field, if you ask me a question, when I last programmed, I can tell you honestly, yesterday. I stopped yesterday at 4, and then I started to prepare the presentation. So I'm working with the computer and with the software on a daily basis. I'm not sure it's usual or not. You can answer that question. If you are still programmer or not, if you are doing the programming, I'm doing the programming. So that's my background, and I think this is also the headlight of the presentation. So there's a very simple question which I'm trying to answer, and the question is how to develop software more efficiently. So I'm doing that every day. So I think it's pretty clear that this is my question, how to improve my work, how to make it a little bit simpler. So, okay, let's try to go my way, and let's try to think. I don't think it will be some kind of precise research talk. Much more it will be about my personal experience, about my personal life, and about story I'm living. So let's try to answer the question how to make a software development a little bit more efficient. But first of all, let's try to speak about the subject of our research. Let's try to speak about the software, because if we want to do something, we try to find an analogy in many other disciplines. So engineering is a not new discipline. Maybe the software engineering is a little bit younger, but we are always trying to find inspiration in other kind of discipline, like civil engineering and many other kind of engineering. But we are working with the software, so let's try to think about the software. If the software is the same as the building, so if you are doing civil engineering, you are developing a building, and let's try to think about the developing of a software. So what makes the software a little bit special? So I think one very special thing about that is that the cost of developing software is mainly about the developing. What does it mean that making copies and delivering copies to a customer costs almost nothing? So it's not like in automotive that you are developing a car and later on you are producing the car. You develop the software, and at the time you have the software done, you can distribute it around the world anywhere in seconds without any cost probably. Yeah, so it makes it a little bit different, because I'm speaking with students or even colleagues, and they ask me who is equivalent to worker in the industry. Who is the equivalent in software engineering? And I don't see an equivalent in software engineering. I just see developers. They are not producing the copies, they are developing a software. So I think it makes software engineering quite different from other discipline of classical engineering. Another fact to have in mind is that source code usually has, on the classical projects, not the school one, has hundreds, thousands of lines or even million lines of code. So it's really a lot of lines. And that's a pity that even one letter matters. So if you change the sign, one sign in your code, it can be drastically different. So plane can crash, car can be lost during the navigation. So there is a lot of symbols, but one letter matters. Yeah, that's really important. And it's a lot. Million lines of code, that's really a lot. It's a lot of books, and you have to know every letter in the book to understand the software. What's another fact about the software engineering, that today we have multi-member teams with tens or hundreds of involved developers during the many years. So it's a large team with fluctuation. Somebody goes out, somebody's going in. So that's a lot of people going in and going out, and they're working on a shared source code. And finally, it's another problem of a software with the property that the software do not degrade with use. So if you have a calculator, you can run it for a million times, and the calculator will behave the same. Yeah? If you are asking why it's a pity, because if you are running with a car, it degrades, and your customer wants a new one. But if the customer has a software, after the 10 years, it works exactly the same as in the beginning. Of course, you can argue that the world is changing, that's really true, but not the degradation of the software, but the change of a world outside took us or forced us to improve the software. Yeah, so that's a world. For me, these properties are very essential when we are thinking about the software itself. Okay, and let's think about the future of software. I think the future is very bright because software probably will be anywhere in the future. So we are happy that we are working in the field of software development. On the other side, since the software will be anywhere, more and more fault of a products will be caused by software. It's clear, more software there will be, the more problems and failures will be impacted by the software. So it means that we have to really think about the quality of software. You know, I think a lot of examples from few of last years, like crash of a Boeing. Yeah? So we are speaking that it's a problem of the software. Of course, it will happen often and often because software takes the main part of the whole product or growth. So that's the reality. Okay, so that's a software. If you know the property, we can start to think about the software engineering, and I would like to present understanding of software development, or how I understand the software development. It's very simplified, the picture, but this picture, I think, will help us to understand the whole presentation. So, of course, the main person or main role in the field of software development is a software developer. At the beginning, we have a problem to solve. So we write down the problem as a specification. Then developer comes in and try to change something what is not executable software, it's a specification of a problem, to something what could be executed. So the developer changes or refine the specification into implementation, and implementation is a source code, and fortunately the source code could be automatically transformed in something what is already runnable into binary code or executable code. So part of our jobs to run the software on the machine is automatized, so it's compilation from or compiling phase from the source code into executable code. Some is not, so you have to rewrite the specification into implementation. So there are many questions we have to answer if we would like to make software development more efficient. First of all, how do we create a solution? So how do we do that? So there is a problem, and how we are finding the solution. Another one is, okay, so you can find a solution, but how you will write down the solution, how you go from solution into implementation. And since there is a lot of people involved in software engineering, I think the most of the time it's not about writing down the solution. Most of the time it's about understanding what already was written. It's about reading the source code, finding interest or intent in the source code, and understanding them. So there are, I think, very important question to be answered if you would like to make a software development more efficient. So let's try to find a task which could be improved. So if you like to something improved, you can improve the tools or you can improve the methods. So let's find gaps there, and let's try to find how to do that, how to improve what has been already done. Okay, so first idea is if you look at the picture, part of the job is already automatic. So if you have a source code written, you are at the end. So you can run a compiler, and as an output, you will get executable code, and you can run the code on target infrastructure. So it would be great if we could generate implementation directly from solution. So if you can specify, from the specification. So if you can specify a problem, maybe even in some formal language, it will be great if there will be automaton which will generate executable code directly from the specification of a problem. Yeah, it sounds quite good. So let's try to search for such a machine which takes a formal description of a problem as an input and directly executes such a specification. So it will be, I think, really great if this could be done, because we probably highly improve the efficiency of software development. So the question, could it be done automatically? And let's try to think about that. If this will happen automatically, we can call the specification executable. So just write down the specification, and you can execute that. Okay, so is it a problem to write down the specification in formal language? Probably not. This is not the main problem to write down the specification of a problem in a formal language. You can use a map or any other kind of formal language, and you can write down the specification. However, it will be not simple to write a machine which will generate automatically for such a specification the product, the final outcome. Yeah? Let's look at two examples. Imagine that you have a problem of transporting message anywhere in the world. You already know the solution. Yeah, it was email. It's called email. So for us, it's no problem to write a specification of an email system and directly generate system from that, because we already done that. So it's not a problem for us. Of course, if you would like to define formally what does it mean sending an email, probably you will formally describe things like subject, the message, the destination, and stuff like that. So it could be done quite simply, automatically. You can write a specification and directly generate from that the product. But let's think about a very simple or quite similar example called teleport. So let's build the same system which takes an object and sends it anywhere in the world. It's called, by the way, teleport. You can pretty formally define such a system. So I can define a place, I can define a subject, I can define what does it mean to teleport someone. So it means that in a time going to 0, you can transfer any objects from one place to another place. So we can write very exact formal specification of such a system. But the question is, could we generate a teleport from that? Do we know the teleport? No. I'm not sure about that we do not know anything about the teleport. So it means that it's not so simple, even if the specification is written in a formal language, to generate automatically the implementation. Sometimes it's simple, sometimes not. So therefore, we still have a developer which will guide the way from specification into implementation. So if the problem was already solved, probably it's quite simple to adopt that solution. But if not, it could be quite hard. Yeah. The question is what is similar, of course, because sending people from Europe to Africa is similar to sending a message in some sense, but not in general. Yeah. So probably this is not the way we will go. Yeah. So we can try this. You can try to find automaton which transforms every specification automatically into implementation, but I think it's quite hard. Yeah. So let's give up. So let's don't do that. Okay, so probably this will be the best solution how to improve the efficiency of software development. So, but it's probably very hard, so let's give up. Let's try to find something another how to improve the software development. Okay, so if we couldn't change the method or tool, let's try to improve the method or the tool. So it will be not the revolution, probably just the evolution, but let's try to do that. Let's try to think how to improve the existing tools which are used in software development. And that's a question for you. What do you think? What is the most important tool in software development? So do you have the answer? So most important tool. If I want to dig a hole, I will take a shovel. So what kind of tool I will use? That's a question for you. What is the most important tool for software development? What do you think? Okay. Great. Any other opinion? Yeah, okay. Any other opinion? So we were really close. Compiler. Yeah. The language. Yeah. The language itself. So if I would like to develop a system, I write down the source code. But the source code is written in the language. So the language is the most important tool for software development. So if you would like to make a huge impact on developing our software development, you have to improve the language itself or method how it's used. So that's my story. That's why I started with the language itself. So let's try to think about language. Let's try to improve the language. Okay. So you already know that. Software language is artificial language. It means that it's created by us, by humans. And this language is created for communication, as every language. And this language is created for communication between two entities, the humans and computers. Quite different entities, humans and computers, the machine and the physical being, but that's a reality. The language itself is crucial for software development, as we already understand. And of course, the choice of a language, because there are multiple languages, the choice of language heavily affects the creation and understanding of the source code. So it's up to us to choose the language or to choose the language and build it in. Of course, since there are two entities, the computers and people, we have to take it in mind. So on one side, it should be executable. On the other side, it should be understandable, easily written, and easily understood by humans. So we started with the binary formats, maybe 10 years ago. We started with very low-level languages, binary format, 0 and 1s, but probably we are not thinking in a 0 and 1s. And we are pushing language further and further, and I'm really happy that today we are not writing the programs in 0s and 1s, that we have much more abstract constructs, much more closer to way how we are thinking. Yeah, so that's the story of a language, and we are always searching for new languages. I will talk about it later on, but if we are speaking about the programming language, the language is usually connected to style of thinking. Let's call it paradigm. It's style of thinking, in a language, you know a lot of different programming paradigms like procedural, logic, functional, object-oriented, and many, many others probably. We have to think such a way to design a program. So this is the language, this is the paradigm. So I think now that's clear that the language is the most essential tool. So question is quite simple. Are there better languages or better paradigms to make software development simpler? There is hundreds of already built or developed languages. I'm sure you know a lot of them. Maybe not hundreds, maybe even more. But you know the C#, C, Python, and there is a fight which is the better and which is the worse. But there is a lot of languages. So the question is, do we need another one? So we'll try to improve the software development. There's a lot of languages, and do we need another one? Isn't it enough? So there's a Python, C++, C#, Java. Are they worse? Are there no good languages? Okay. I'm not here to answer the question, but if you think about the languages, there are different kinds of programming languages or software languages, to be much more exact. On the one side, there are general purpose languages built to write down any kind of algorithms with the power same as the Turing machine. So you can define or write down any algorithms in them. You know this kind of languages like general purpose languages, Java, C#, and many, many others, general purpose languages. But on the other side, there are a little bit different languages, not targeted to write down any algorithm, but they are targeting to domain, to very specific domains. Let's think about the inspiration from the other industry. So let's find analogy. The hand. Hand is a very general tool. You can do anything with the hand. You can eat, you can dig. It's very general. Maybe it looks for you that it's quite simple to work with the hand, that it's very simple. Honestly, I'm not sure it's very simple. It took maybe 5 years for children to learn how to write or learn how to draw pictures. You know the artists, they are much better than me. So it took me maybe 30, maybe never. I will never use my hand as the artists could do that. But it's a very general tool. On the other side, we have a very specific tool, like a shovel. It's much more simple to dig a hole with a shovel than with the hand. Oh, of course, it's a little bit harder to weed with a shovel than with the hands, but it's a domain-specific tool designed to improve the efficiency, not in general, but in very close domain. So the question is, okay, so if there are specific tools in other kind of industry, could we find such a specific tools also in the software development, which will increase not software development performance in general, but it's some kind of domain? And the answer is true. You can find an inspiration, and you can build a language, not a general purpose one, but targeted to specific domain, which will increase the productivity in such a domain. And you know, not hundreds, you know millions of such languages, I'm sure. Some has no names, but you know them, like HTML, CSS, SQL. You couldn't write down algorithms on finding shortest path in a graph using CSS. It was not designed to doing that. It was designed to simplify the problem of visualizing elements, to giving a style there. So there are hundreds of them. So if I was speaking about the languages, I'm not sure about building the GPL, but I think that we are building specialized domain-specific languages because they could improve the efficiency of software development. Okay, and now let's try to revisit the idea of domain-specific languages. We know that the language is designed for a very close domain, or very specific domain. And let's try to think, what is a software language? Yeah, you know the Chomsky hierarchy, you know context-free grammar to define a syntax probably. But let's try to think not about the textual languages. Let's try to think about language as a way of communication between the humans and between the computers. Okay, so the language could be textual, like C#, but it also could be graphical, or the form one. If you take the idea, you will realize that every user interface of every application is, by the way, a language. So if you take a Word, it's a language. If you take Excel, it's a language. So if you are dreaming about the visual languages or very fancy languages. You don't have to do that. We've done that already. So every user interface of every application is a language. Not the general one, but the very specific domain language. That's how we increase the efficiency. Now you don't need software developer to write down documents. You have a Word. You have a perfect, smart girls and guys to use a Word to write down the documents. So we've done that already. So that's not also the story of that, of course. So the language could be even the form base. If you accept the idea, you will recognize every UI as a software language. You will recognize every API. So you have a library, and you are using the library. So you are using the domain-specific language. Using that library, you can send a message. Probably you will not find the shortest path in graph, but you can send a message. It's a language of sending messages. So that's why DSLs are anywhere, and they're really proven strategy of making the products or software development simpler or more efficient. Yeah. So we are building the application, building the DSL. I met my colleague from other department, and they told me, "Oh, I see the future. I see the no-code platforms. I see the low-code platforms. Have you ever heard about that?" Okay, I heard something about the no-coding, about the low-coding, and he presented it to me like a new paradigm. So, okay, and honestly, it's a not new paradigm. We already know that for tens of years. Word is a low-code or even no-code platform. If you disable the macros, it's no-code. If you turn macros on, you can do a low-code. So it's not a new fancy feature. It's just another kind of a language. Domain-specific language. So someone's decided to build a language which trades generality for being better in specialized domain. So it's not new approach. Okay. Okay. Going back to languages, and I already told that you are building the languages even without names. So you build the system, you deploy it to your customer, and your customer decides that the system should have some kind of configuration. Yeah. So, okay, so perfect. Just tell me what you have to configure it on your own. And the customer tells you, okay, I would like to configure logo and maybe the directory where the program will start and stuff like that. So you are building the very little language called configuration language. Probably this language even has no name, but this language is really dedicated to your customer. So no, not you will use that, not your developers will use the language. The customer will use the language. So the time passes, and your customer asks you for more and more. So your language becomes more complex and more complex. It started with a very simple configuration language. Maybe after a few years, it's quite huge language, even GPL. So the question is, okay, so how to make a language or configuration much more general. Yeah? So you decide, okay, you tell me that you would like to more and more experiment with your system. You would like to have a more and more configuration. So how could it be done? Very simply. This is the image which explains that the zero and total configuration is the same. So it even doesn't solve our problem. Very simple. So from the beginning, we have a source code. It's probably the source code owned by the company. You take the compiler, and as an output, you have executable code. And now imagine that this system has an empty configuration language, so nothing could be changed using such a language. So it's very simple. It's one part of a story. And now let's try to think about absolutely configurable language that you give your customer system, which could be totally configurable, totally open. How problematic is that? It's very simple. Don't give him any configuration language, just give him a source code. So these are two different sides, but they just shows that the problem is not about the low level of configuration and the high, but the truth lies behind. It depends on your customer. If you give your customer the source code, by the way, you make your customer a software developer, and the customer will not need you anymore. So think about that also. So it's not a problem to make a totally configurable system. It's very, very simple. Just don't give him the compiled code, give him a compiler. So if you are thinking about the language, if you are thinking how to design such a language, you have to think about the customer, you have to think about the communication, and the language itself is somewhere behind that, between the full configuration and zero configuration. So we will come to maybe the language pyramid, which one language is built on the top of another one, trading the generosity for the simple of use. So there are multiple languages, and they are compiled vice versa. So from higher level to lower level, and what we have done, that there are different users, and these different users have different experience, different knowledge, and they work with a different kind of languages. So one could work with CSS, another one could work with HTML, another one could even program something dynamically and connect to database. So that's how we can do the software development more efficient, because we are involving more and more people into the industry. So not everyone will work or program in C#, it's a general purpose language. Some of them will work with specialized languages. And it's true now, because if I'm looking around, everybody uses computer. Of course, I know that you are computer scientists, but if you will look around using our domain-specific languages in the context or in the form of AI, of UI applications, everybody is now working with computers, so we done that great. So now we involve anybody into the field of software development on the different levels of a pyramid. Some uses very simple languages, like just sending an email, which could be 20 years ago quite hard. Some uses much more complex languages, much more general purpose languages. Okay, if you are thinking about the domain reflection in a code, why the domain is very important, and if you are using the general purpose language, you can even see that the domain is usually reflected in a code. If not, it will be very hard to read such a code. So this is the piece of a code from a Java, and if you look at the code, if you know the Java, or it's a very general program, if you read the code, it's quite obscure. The question, what this code does, I don't know. There are very specific names because the domain is not reflected there. Let's look at the same code with the domain reflection. It's the same code from the point of view from the structure. So for a computer, the first and the second one is the same, it's just the names, but not for humans understanding the domain. If you look at the second code, what it does, if you look at the code, from first, except it was very, very hard to judge because it means nothing. And from the second one, what do you think? What is the domain of the second code? Yeah, bank. It's about the transfer. So the structure is the same, for the computer is the same, but not for us, because domain is reflected directly into code. So for us, it's much more simple to read and to understand. Okay. Okay. So that's why maybe my past research and even today research was concentrated or was about the software languages. So I've asked the question how to develop a software language much more simpler. So we came to the idea of language patterns. We studied not just artificial languages, but even the natural one to discover recurring patterns, because if you find such a patterns which are used in human-to-human communication, it will be much more simpler for humans working with the computers to use such a patterns. We even have a lot of experiments in such a field. We also implemented a tool for defining new languages. Of course, many of them are domain-specific languages based on application of such a patterns. So that's why my research was concentrated to language. We also done the research in the field of adoption of existing language. So you can define a new language. Another strategy is not to define a new language, but take existing one and change it to your needs. It could be done. Yeah? It's like in language adoption. These kind of languages are called internal languages. You can take Java, and you can take Java as a hosting language for your domain-specific language. Why we are doing that? Because if you take an existing language, you can also take with the language the whole infrastructure. So we decrease the cost. Because the main problem of designing a new language is the cost of designing such a language, and not just the language, but the whole infrastructure. So there are two ways how to do that. Try to build a tool for designing a new language, or try to build a tool which takes existing language and try to adapt language for another kind of job. If you're thinking about the one language could have multiple notations. It's not just about one notation. So the same language in the context of the concepts, so they are same concepts, could have multiple forms. One form is maybe suitable for one kind of person or user. Another form is much more suitable for another one. So the same language in the things of context or concepts and their concatenation is called abstract syntax. Could have multiple concrete syntaxes. So the same language could have a XML notation, JSON notation, and graphical or even form-based notation. And the user will select the notation which will or is the best for her or for him. Of course, it depends maybe on the maturity of a user. So simple to start with the blocks and later on go to text. Or it could be even influenced by the size of the projects. So it's much more simpler to look at the graphical representation if it's smaller and much harder if it's larger. You have probably heard about the class diagrams. It's great if you have few entities there, 10, 20, but imagine you are looking at the class diagram with hundreds of classes. And I'm speaking about the visual notation. So sometimes this is better, sometimes other form is the better. And what is the lesson learned if you are thinking about languages? So if you are trying to develop a GPL, general purpose language, it's quite time consuming. So I not suggest to do that. So if you'd like to improve the efficiency of software engineering, I think the building a new GPL is not the best strategy. You can try to do that, but it will cost a lot of resources. You need to build a community. So some languages are really great, but with very small community. The process of adoption of a tool or technology is very hard in the industry. So think about that. You have to port the libraries. So there is maybe just a few constructs, maybe hundreds constructs are in the language itself, but there are thousands of libraries, and you have to port that, of course. And you have to rewrite the APIs. That's why we are today taking, if you are building a new GPL, we are usually taking the strategy of reusing the existing infrastructure, like in .NET, or the authors of a Kotlin decided to reuse the Java community. So they build a new language, new GPL on the top of existing community of a Java framework. Okay? So it was a way how to move faster, how to do that a little bit simpler. If you are thinking about DSL, I think the building a DSL is an everyday job. So if you are building a software system and there is a configuration inside, or many other things, you are probably already developing a DSL. Some of DSL are very simple, some are quite complex. Some of DSLs even become after use a GPL. And just to know that there are language workbenches. So it's language-oriented programming. I think it's called also Paradigm, born maybe 15 years ago. The idea of language workbench is to make language development simple. You can find real industrial project in such a category, and you can play with language workbenches. Maybe you heard about the Visual Studio DSL tools, or if you know the JetBrains company, they got the MPS. Yeah, it's an ID to build the IDs. Yeah, so if you use JetBrains MPS, you are practically have an ID which is dedicated to build IDs. Okay. And later on, we have a lot of experience in the different fields also. So if you would like to do also research in software development, it's good to know the mental model. So we have an experiments behind us about the forming mental models, very simple experiments. So we imagine a source code, and you give same tasks to 10 developers, and you're watching them how they behave. So they are building a mental model inside their heads about the source code, and we try to experiment how these mental models overlap. Because if they overlap, if it will be much more simpler to write something into code to understand or write for another developer will understand that. So it's quite good to know how they behave, how they share the mental model, how to write down what they have inside their head into the code just to share their experience. So that's another, I think, quite good strategy and a very nice discipline to play with developers, to find how they build model, how they share the model, how these models overlap, and how these models could improve the efficiency of software development. We also play with visual enrichment of a source code. So if there is a lot of information, it's good to find some kinds of elements which will enrich your code. So we play with visual enrichment. We've done a systematic mapping study to find which kinds of elements are used in today's ID to put inside another kind of knowledge, another kind of information, and how to interpret such an information. But what's a really problem? Today we have a problem not of missing information. Today we have a problem that during the development you have much more information that you need in such a field. So the source code is large, and it's very hard to find the intent in the code. So we played with the software source code projections because personally I believe there is no one-fits-all view of source code. So it's great that everybody could construct its own projection of a source code. It's like if you are building a house, if you have a model of your house, and if you will go to buy the window, you just will care about the windows in the house, not about the other stuff like doors and many, many other things. So it's great to have a tool which will help you to look at the code from the viewpoint of your personally defined projection, because otherwise you will be very influenced by the vision of the developer or vision of the developer of the structure of the code defined by developer of our original source code. Yeah, so that's another story. And finally we came to so-called dialogue-based software engineering. Maybe you heard about the prompt engineering. We started it a few years ago because we already realized that even projection is impossible to done the projection in one step. So it's not about the querying, it's about sending the query and getting the projection. It's about the refinement. So now we are playing much more with dialogue-based software engineering. It means about creation of such a projection in a series of dialogues. So you specify your query, you get the result, and later on you can refine what you are looking for. Yeah, so because it's always about the context. You have a context in mind, and you have to share somehow your context from the mind with the machine to understand what you are searching for. Okay, so we are at the end of our talk. Thank you very much for your attention, and I think now it's time for questions.
Thank you very much. I realized I took over this session to Marian, and it seems that it is going to be like this for the rest of the session. Well, questions?
Okay. I'm interested, do you have any case studies running on the using chatbots for the designing these dynamic domain-specific languages? Maybe you are running some interesting studies with industry or with students.
Yeah.
This is
not yet. We don't have the final results, but a few of my master students are working in the field of using chatbots during the software development to understand what could be done and what could not be done using such an approach. They're using the many different kinds of chatbots, but these models are usually statistical, backed by the formal grammar of a language or model of a language. it looks promising on a very short example, but in reality, we have a code with millions of lines of codes. So it's not about the general questions. It's about my situation, about my context. Yeah, so I still believe that it could be done, but not just general experience will be the input of such a dialogue system, but also the whole source code, as well as all the other artifacts, because not just the source code is the artifact of software engineering. There are other reflections of a domain like specification and Git logs and stuff like that. I hope in the future we will put it all together, and such dialogue bots will work quite perfectly. So no result yet, but we believe in that.
And do you think that some database of the examples would be needed, of like in some lower layer language for doing this chatbot based development of?
I think that at least there's still a lot of things to research, but I think that free models are very essential for such a dialogue-based system. It's a model of a software or your product, of course, because the question should be answered in the context of your product. It's about the model of the source code, but all other artifacts. Of course, the model of a human-computer interaction, it means like a synonym and stuff like that to understand the meaning of a natural question. And the third model is the model of programmer's knowledge. So there is a knowledge spread around the world. So you are solving such kind of problems within your context, but you can reuse the knowledge from other projects. So yes, there should be a model. Some of the models, I think, are statistical, but always baked, but they should be probably somehow baked by the, I'm not sure how it's called, not formal grammars, but languages are, software languages are formal, so this formalism is also included in the decision making. Yeah.
Any other questions?
Thank you, sir, for the wonderful lecture. One problem that I can see in the language, I think one language is not all in one.
Yeah.
To work in different contexts, in different domain. How is it possible and feasible to get different features from different languages and create another language to work with different domains?
Thanks for the question. There are multiple languages. Yeah, there are natural languages, like one speaks in German, one speaks in Slovak, one in English. That's one point of view. We are not doing research in such a field because there are models for translation between the languages. I think it's quite well researched. But what is really true, that even one system is not built in the same language. If you look at the classical today system, I think a software system, it's built in the GPL. There are probably HTML, CSS, and SQL, and the C# and the Java, as well as the logs are in such kind of system like logs from Git. There is a CI/CD configuration. There are even some informal written requirements, test casing, and stuff like that. So we have to mix all together. So of course, you have to find what is similar, some references between the artifacts. Some of them could be defined quite formally. Some of them should be discovered because some of the artifacts are written in informal languages. Yeah. So you can use statistical methods, like you have a name of a variable, and you will search for the same variable or for the same token inside other kind of artifacts in the specification. So of course, you have to find references between different kinds of artifacts, if I'm speaking about the software itself, not about the different natural languages. Yeah.
Any other questions?
Thank you for your presentation. I would like to ask if domain-specific languages are not too restrictive when they need to be merged. For example, if I have a domain-specific language for creating software from UML and another one for example, from Archimate, if because these languages need to be restricted in some way and extended in other, if there is not problem to merge them and managed in some way together.
Yeah, there was always problem, because if you have two different languages with the different concepts, and if you want to put this information together, is very similar to previous question, you have to map the concepts from language one into another language. Yeah? But it's the same problem like in natural language. You have a head in Slovak and head in English. You have to tell that these are the same symbol, but with different concepts. Of course, there is a problem. You can find maybe some statistical models how to do it automatically, but if there is languages are formal, it would be much better to define the formal transformation between, and it costs a lot of money. Yeah? If you define the conversation between many of languages. Yeah? But that's pretty natural. That's why we are always trying to find the standards. So there are 20 years ago, there was a lot of standards for doing some things, and today it's one standard, like HTML. Yeah? So 20 years ago, there was a lot of things how to define the user interface. We are today mostly using HTML and CSS for doing the UI. Yeah? But it's very true. It's very hard to because it's about the finding translator, automatic translator between different kinds of languages. It's not so simple. Something could be done statistically, something not. You can always do that writing by the hand, but it's quite expensive. Yeah, that's true.
Okay, thanks. And answer if it's if the benefits are if benefits are not too much in comparison with the problems. Are domain-specific languages still good to maybe optimize some things, or they should be changed or somehow managed?
Yeah. I hope I get the idea behind that. You are the developer, you know the GPL. So for you, is DSL not very important because you can do anything in the GPL. So probably for some kind of people, DSL are not very important. If I need to do something on my computer, I can take the C# and run out the script. But you have to think about other kind of people, like using the Word. So they can do the same using the script programming, but I couldn't imagine that. So that's answer to your question. And that's usual mistake when someone wants to create a new DSL. They try to create a too general DSL, but it's very simple to create a too general DSL. Just take GPL. Yeah, so that's the answer. So
thanks.
Thank you.
Okay, we have just 3 minutes of our recording, so other questions wouldn't be recorded. So I think not enough time to pursue this discussion too much further for the recording, but nevertheless we can continue, and in the panel discussion we will reopen this topic. I wanted to ask you about intentional programming, about the approach that Microsoft created some more than 20 years ago that enables you to create abstractions for yourself, and then it died in favor of .NET, and about preserving use cases in code. But what I was thinking about, and I don't think that we have enough time to answer this here, but for the panel discussion, how much does all this programming, the software development, teaches us about ourselves, about human mind? Because we are actually reflecting human mind, making this working, making things in our mind working, and this is just amazing. And I don't think that too much effort was invested in this.
Yeah, this is my last slide, but there is another one, and I think it's top secret slide. And if you would like to improve software engineering, I think you have to invest to learn to understand the people, not computers. So that's how we think about the mental models, how the people communicate together, because we would like to make a machine to be much more closer to us. So first of all, we have to understand us. That's really true.
Thank you very much for this amazing keynote. So let's thank the speaker once again. So and you will join us for the panel tomorrow, and we will continue with this discussion. Thank you very much.
Thank you very much.
I must be careful not to break the mic. They said this is a very expensive thing. So now we should go to the city tour, or if you don't want to join the city tour, you can come on your own to the restaurant. The location is on the website. Jano will tell you more.
Thank you very much. So the city meeting point is at the Slovak National Theatre at 5 p.m. From this place, we will go through the old town, up to the hill, up to the Bratislava Castle, where in the nearest there is a restaurant called Parlamentka. Parliament restaurant, and we'll have the dinner there. So, if you are familiar with this, we can meet at the meeting point. You can find this in your email box. I send you the email. So, oh yeah. You can go directly there. You also have